Welcome to the HC Commodities Podcast, a podcast dedicated to the commodities sector and the people within it. I'm your host, Paul Chapman. This podcast is produced by HC Group, a global search firm dedicated to the commodities sector. Today we're talking fusion and fusion power. Right now there's a coalescence of technologies such as AI and materials science that are making it ever more feasible, as well as a groundswell of interest from public and private investors. What is fusion power? What would it mean for the world if it was deployed at scale? Who are the investors? What are the technological changes? And what would it mean for power markets? To discuss all that is Jay Brister, an independent consultant with 40 years of experience at a global level in nuclear energy in all aspects of operations, engineering, technology and commercialization. And Jay has spent the last 5 years of his career zoomed in on fusion. As always, you can really support the show by leaving us a positive review on the platform you're listening on. And as always, I hope you enjoyed the episode. Jay, welcome to the show.
Thanks. Glad to be here, man.
So we're talking fusion and fusion power, and I've wanted to do this episode for quite a long time. Obviously it has profound ramifications if we get this right. It's important when we get this right in terms of the energy transition and so forth. But let's start at the very basics. Can you just give us a sort of top level overview of what we mean by fusion versus fission and what we mean by fusion power?
Sure. And I'll do a little preemptive chat about fusion here as well. So to get us started, I think fusion really is going to be a transformative energy technology. So where we sit today, it's advancing quicker than ever towards proving that it is a viable technology, but that's driven by significant private funding, emerging government support in both regulatory constructs and public sector funding, and advancements in what I'll call enabling technologies that are allowing the technology to actually be delivered. And AI is moving into that mix as well. So it's not without its challenges, but this private sector is forging ahead to address those. And we'll get into more of this as we go on. But some basics around fusion, call it, Fusion 101. Fusion is basically what happens on the sun. So fusion works. It's there. It's keeping us all warm. And here's a common reference you'll hear when folks talk about fusion development. That is trying to put the sun in a bottle. And that's really what we're doing. It's trying to create this unique set of conditions that takes fusion fuel, which typically is two isotopes of hydrogen. It's deuterium, which is H2, tritium, which is H3, and creating the right pressure and temperature conditions in which those two isotopes of hydrogen are fused together. And when that happens, there's a tremendous amount of energy released, and then you produce helium and you produce a neutron, and you produce a very high energy neutron. You produce, in prompt neutron speak, it's a 14.1 MeV neutron. So it's a very energy dense source of energy, several times that of fission. But when you ask, what's kind of the quick contrast between the two technologies, the biggest differences I think is revolve around kind of the safety advantages that fusion presents against fission technology. Not to say that fission's not safe, it's just another level of safety that is inherent within fusion technology. Meltdowns are not possible. There are no fissile materials in fusion. There is no long-term high-level radioactive waste, specifically like used nuclear fuel, where you're looking at almost an indefinite decay time for the isotopes involved there. And then there's a very, very low non-proliferation risk associated with the technology. So it is, uniquely poised to be, a clean, zero emission type of energy. The fuel, deuterium and tritium. Deuterium is the main source. It's abundant. It comes from seawater. The power source itself is being designed to be scalable, be a base load or power following type of resource. So a lot of things kind of going into the mix in the development of this new technology, Paul.
Yeah. What does that non-proliferation piece mean? Is that in the nuclear weapons aspect? Or?
Yeah. That's right. So it's just, there's In this technology, again, the if you look at the treaty conventions, it's all focused on special nuclear material and proliferation of that in the development of weapons. There is no special nuclear material involved in these, these private commercial fusion ventures that are looking to develop power plant technology. The radiological isotope involved with fusion technology, is tritium, and it's something that is known. It's manageable. There are, current, regulations regarding export control that govern how that is moved around and used. So it's not a threat from a non-proliferation perspective. And there's a lot of work going on in that space because, of course, all of the existing treaties are silent on fusion because just like when the Atomic Energy Act of 1954 was written, fusion wasn't on the radar screen. So it's addressing this and addressing what's applicable and what's not applicable, and then in most cases, how kind of existing constructs will satisfy the deployment and commercialization of this technology.
So it's sort of the theory side is that the fuel is more abundant, the waste products are far less dangerous to humans and the environment, and you're also yielding so much more energy for the fuel consumed as well. Tell me if that's a sort of a right top level analysis. And then is there any sense in terms of I guess the scale of this? There's the ongoing challenge at the moment of getting existing fission reactors. There's lots of talk about SMRs and so forth.
Mhm.
Is there any sense about how nuclear or fusion can be, when they get it right, used at different scales and so forth? Or are all going to be 2 gig power plants or anything along so that piece?
Yeah. Yeah. So first, I mean, your summary was correct. That was a good quick summation there. And then this technology on the private side of things, I would say in general, you're looking at about a 200 to 400 megawatt facility. Of course, you've got kind of bookends on all of that as well. You've got quite a few technologies that are looking at kind of micro applications. And then at the other end of the spectrum, the kind of global International Thermonuclear Experimental Reactor, ITER, which is in Cadarache in the south of France. It is a demonstration machine now, but their proposed power plant is a very, multi-gigawatt facility. But private sector is kind of in that, I'll call it, I'll put it in quotes, SMR range of technologies. And when you think about, how this technology can kind of fit into the energy markets as we go forward, it's kind of a one-for-one replacement for these SMR technologies. So a lot of, very, very similar applications, size-wise. It's non-weather dependent. It's 24/7. It can load follow. That's what's, being, postulated in designs today. So it's something that if you're thinking about fusion and you know a little bit about fission and SMRs, it's kind of a one-for-one replacement.
And then just staying on that science piece, because I'm imagining some of these terms are going to come up when we talk about what advancements have been made and how new technologies are unlocking some of the historical challenges. You spoke about bottling the sun. What are the sort of the components to doing that in general that's common to all these theories and technologies?
So maybe at a high level, the approaches to fusion today are in three basic categories, three different kinds of fusion. One is magnetic confinement, where you use these large magnets to magnetically confine a continual burning plasma that's going to be creating that heat energy. That heat energy is then transferred to a medium to boil water to turn a turbine to produce electricity. That's a tokamak kind of design. And a variation on that is a stellarator, where you've got kind of a twisted tokamak design that's providing that same kind of outcome. On the other end of the spectrum is inertial confinement fusion. This is a compressive type of fusion application. This is, in most cases, done with high energy lasers. For example, the Lawrence Livermore facility out in Southern California that recently has achieved what we call scientific net gain. So they've achieved more energy out of the fusion reaction than they've put into it. So in 2022 and 2023, they've demonstrated advancements in what's known as net energy gain, or referred to as Q. And then, kind of in the middle, you have magnetized target fusion, or magnetic inertial fusion, where it's kind of a combination of both, where you'll have a magnetically confined plasma that's compressed by some method, whether that's physical or with lasers or others. The company I recently worked for is General Fusion up in Vancouver, British Columbia. We were using kind of large pistons to physically compress a plasma to create fusion with that company. So you've got several ranges of those. I think the predominant approach today is tokamak, which is where there is been kind of the longest development. Really started back in the 50s with the Soviet programs that began to move that technology forward. But as we've seen, significant advancements in inertial with Lawrence Livermore, and several of these private companies taking alternative approaches have achieved, funding levels, greater than 300 million US, and are progressing their activities as well.
Yeah, and that's really sort of the key story here. Is part of it's technology, but it's part of it's also the arising of, well, global competition, but also these private companies, and we'll get there. Just in terms of that technology, can you just give us a few minutes on the history of this? Because you ask, talk about fusion in general terms, people are sort of, it's always 10 years away kind of thing,
Yeah,
like
yeah, that's right.
what's the history of investment and understanding these technologies, and is that accelerating?
Yeah. So they'll take that from two different angles. One would just be the kind of the purely scientific aspects of this. So in fusion space, we all say we're standing on the shoulders of giants that have just done tremendous amount of work, really over the last 7 decades or so. I mean, the first experiments began back in the 30s. Post-war U.S. is when a lot of advancements were used in fusion, more so on the weapon side of things. But as Eisenhower came on board and Atoms for Peace, that really began kind of this collaborative global approach to nuclear technology. The Russians began tokamaks, back in the 50s, and then 60s, 70s, 80s, 90s. It was all about continuing research, baby steps, and different ranges of government funding in different countries around the world to advance fusion, to the point that the collective kind of public sector is beginning to make some inroads into advancements in the technology, just within the last couple of years, as I talked about with Lawrence Livermore and what's been going on with the inertial confinement approach. The private side has been kind of the wild card in this particular sector. It's a sector that started right at the turn of the century. So the oldest companies are a little over 20 years old, and there's just a couple of those. But predominantly influenced by almost exponential growth in the sector just over the last 3 to 4 years. And it's it's kind of the combination of kind of the advancements in science. So as the scientific community digs into this with advanced research and development and large scale, public sector projects, on the academic side, we've reached the point where we're actually beginning to confirm plasma theory. The science is getting much more solid. We've achieved a scientific net gain, and the ability to use models, use simulation to drive design is moving forwards. And also, I would say on that side of things, I guess the last, you know, about 5 months, I managed a study for the Clean Air Task Force that was sponsored by AWS, that looked at how artificial intelligence and high performance computing were actually enabling the advancement of fusion technology. And I would say it was a mind-blowing experience to see how AI and HPC come together to take certain timelines of things from years into weeks. So that side is advancing very strongly. The enabling technology component of that, so things like development of high temperature superconducting magnets and HTS tape, is allowing the creation of very compact, super, 20 Tesla magnets that will, fit inside my office, as opposed to the 11 or 12 Tesla magnets that are 4 or 5 stories tall in the ITER project in the south of France. And then lastly, it's this, money makes the world go around, right? So it's this investment shift on the private side of things that's really been the game changer, I think, for this sector. So we have companies that started around the turn of the century, and it took from the turn of the century to 2018 for the first $1 billion of private investment in aggregate to go into the private fusion sector. But from 2018 to 2021 was the next billion. And then since 2021, and this is nearing the end of 2024, in the last 3 years, close to another 6.5 billion of private investment has gone into this sector. So we've gone from two companies to almost 50 today. And with this, large scale, I mean, relatively, for this particular sector in global energy, this is not a really big number, but it is really big to this set of really intellectual property companies that are advancing technologies that have taken, their outlook and looking at demonstrating proof of concept for these technologies in the next couple of years, and prototypical power plants early in the next decade. So it's a very, very active sector. That's the private side of things. When we can talk about the
Yeah.
public side later if you like, but that's kind of the lay of the land.
The energy and resources sector is experiencing unprecedented change. To help companies navigate this world and capture its opportunities, HC Group launched Enco Insights in 2023. Enco has rapidly become the leading global expert network dedicated to energy and resources. Enco Insights leverages HC Group's 20 years of connections and dedication to the sector to give clients the expertise they need to take decisions fast. Connect with Enco's experts for anything from a 1-hour insight call to a longer-term consulting project at encoinsights.com.
And I want to come on to the drivers behind that private money and also the geopolitical competition here in a moment. And you used a fantastic phrase when we first chatted about actually in silica, this idea that actually with new AI,
Yeah.
lots of this, as you said, you can take in development times down to months instead of years by being able to test in the computer as opposed to in the lab. So it seems like it's material science. How do you better contain this plasma? How does the materials themselves not degrade? It's AI, both in modeling how to do that, but also using AI to contain that plasma that's part of the game changer here. So just a moment on the economics before we move into the investors. Historically, as you've highlighted, this has always been at the governmental level in many ways just because of the scale.
Yeah.
And you also face, and this is where it's got some commonalities, or it's presumed commonalities with nuclear today, where you've got a much higher levelized cost of energy than what we've seen, renewables and essentially over the last, you wouldn't believe it if you sat in certain parts of the world, but the cost of producing energy continues to drop. What is sort of the economic theory behind this, or is sort of economics out the window because if you get this right, it's essentially a limitless source of low carbon power?
A great question, and of course, that's the question that's on everybody's mind as you look at a new energy source, and it has to be economic. And I would say, I stepped into this space about 4 years ago, and that was just kind of in the beginning of when we began to see kind of this larger scale investment come into the sector. And with money allows these companies to grow organizationally and grow in diversity of who they are as an organization and what they're about as an organization. And I guess my kind of lay of the land, how things are evolving is, I would say in the last 4 years, you're moving out of this is science. I mean, this is, please wear long pants to work. We're trying to develop a business here, it's not just heading into the lab and playing with the science side of things. To the point that in May this year, I had the opportunity to attend the first kind of public-private get-together at the ITER site in Cadarache. And I think there were just north of 30 private companies that attended this to engage with ITER. And I think my biggest takeaway from these 30 plus companies gave a quick presentation on who they were, what their technology was about. These private companies really surprised me with their approach and the outlook in the development of their technology, because in addition to being a clean energy source that's going to be present to address climate change, the other fundamental that's built into kind of the DNA of all these companies is the recognition that they're producing a commodity with their technology. It's electricity. It has to be competitive in the marketplace. It has to be competitive with natural gas, which is kind of the global standard at the moment for competition. And if they can't do that, they realize that their technologies are not going to market. So that was kind of a big aha for me, just listening to these companies today as opposed to where they were just a few years ago. So the staffs of these organizations are beginning to include very sound, commercial people who understand global energy markets, and then the further kind of diversification of the development of the technology. About half of the companies, a little over half of the private fusion companies are concentrated in North America and predominantly in the United States. But then there's a pretty good, scattering of companies across the EU, some in Japan and elsewhere that make up the rest of this. So it's a global outlook, but some firm commitments to developing an economically viable energy solution.
I don't know. This is an idiotic question, but is there the sense here that it's kind of winner takes all? It's first to get to the technology that works, or are we likely to end up with a range of different approaches?
I think, with the current approach of the sector, with, kind of multiple shots on goal here to kind of see who can score a goal, I think it's about how many goals get scored and kind of not who collectively wins. So I think there'll be regional players in this, because as we continue to talk about this, you can see how the public sector is in engaging with the private sector these days. And just like any other business, energy is the main focus here, but the other aspects of fusion technology are it's going to be a huge economic benefit driver for these host communities that take on the technology, and for countries that need a technology, and energy is the lifeblood of any economy in the world. Regional players, I think, will be able to monopolize on that, especially with regional deployment strategies. So as long as we get to multiple technologies that are economically competitive, it's going to be I'd love to see it, just like what kind of car do you want to buy, right? So they're going to all provide the same function, but it's just kind of the best fit for who you are, where you are, and how that application can fit into the specific needs of a specific energy market.
Yeah. Let's talk about that public investment. Who is doing it? Is there a geostrategic backdrop to this? Is there a real sense of whoever gets fusion up and running has a significant advantage, and kind of some sense of the scale and quantum investment we're seeing and how that trajectory has changed?
Very pertinent question, very timely question, and just a couple of things. Awareness of this is beginning to, kind of bubble itself up to the surface, and kind of the geopolitical implications of fusion development. And then just for listeners, there have been some great references in the Wall Street Journal on their video page, and also in some articles that have been written just in the last few months that really get into this in detail. And not to mention, in September, there was a great fusion hearing in the U.S. Senate that was led by Senator Manchin that spent a significant amount of time of the hearing on kind of this geopolitical the implications of developing fusion technology. So, are there geopolitical implications? Yes. I think it evolves around who is going to do this first, who is going to influence the codes and standards that are pretty much non-existent today for the development of this technology, and to be able to design technologies to meet the necessary safety codes and standards, where those originate from, the strategic kind of competitive advantages that you can have as these codes and standards are structured from a longer term manufacturing and delivery of the technology. So, to put it in context, the US government has been funding fusion for decades, and most recently, close to $1 billion was the annual budget for the U.S. government's investment in fusion. But other governments in the world are beginning to see the need to support that in their geographies as well. The EU is about $650 million a year. The UK is about $350 million a year. Germany just announced, I think it was last year, that they're going to put $1 billion into fusion R&D between now and 2028. So, ballpark $300 million a year. And Japan is stepping up as well, with north of $200 million a year invested into development of fusion. But the real wild card here is what's happening with China. China is far outspending any other country in the development of fusion technology. Estimates are around $1.5 billion a year. And as I mentioned, there's just a great video that kind of shows the transformative nature of what $1.5 billion a year can do to a development program, and a little video that the Wall Street Journal has. So they're moving forward. I mean, and then kind of the West is moving forward. So is there a race? I mean, I definitely think there is a race. It's a race for energy security. It's a race for providing energy solutions to emerging countries, and the furthering kind of geopolitical relationships that go on in that front. And then I think underpinning that, though, is going to be the ability for different countries, different large scale utilities wanting to have a technology that is viable, not only technologically, but also from a regulatory construct perspective, and having a technology that is endorsed by Western safety regulators, I think weighs into how these markets will evolve as well. So if you think about a new technology coming to market, especially for fusion technology, I think the first rounds of customers are going to be in Western markets, where that pathway is least encumbered from a regulatory perspective. It's probably least encumbered from a financing perspective. So the quicker those can get to market in private transactions, that will set the stage and be a strategic, I think, advantage to the West, as opposed to the Chinese, who have been trying really for decades to get into Western markets with their nuclear technologies, and have gotten close. Almost did it in the UK, but the crosshairs are still in Western markets for their technology.
Yeah, yeah. There's quite a bit to unpack there,
Yeah,
but
yeah.
a couple of episodes there, and we've covered that sort of geopolitical competition and the impacts quite a few times. The other cast of characters, we've talked about private investors, but it
hmm
seems very much we see Bill Gates, Peter Thiel, many of the sort of Silicon Valley, sort of the river crowd, people are aware of that
Yeah.
phrase, who are investing big in this. Is there any sense of why they're doing it?
Well, it's this is the only market, and I've been doing business development for the last 25 years. This is the only market that I've ever worked in where people routinely talk about market size in the trillions of dollars. It is a completely transformative technology. And in my mind, it's almost like the horse and buggy to automobile kind of shift in a particular sector. And for these investors too, the amount that they're putting in now, even though there are some large numbers in a relative scale, it's a very minor play for these kinds of investors. But I think it's also worth noting that the interest in this sector has evolved just over the last 4 or 5 years from high net worth individuals to sovereign wealth funds to companies who are looking to invest to further, a separate technology that's their own and is going to be supported by clean energy to produce things like, carbon-free steel, and then just overall, energy investment kind of VC firms that see the same thing. So it's on this spectrum of, millions to tens of millions to hundreds of millions that are invested across this range of investors with very, very different risk tolerances, into the sector. But in aggregate, you have, this very unique landscape where, just within what was it, within the last month, you've got a company that kind of comes out of stealth mode, Pacific Fusion, with a $900 million seed round fund, right? So it's these kinds of things that are going on, and it's the interest in the sector, the potential, and it's really going back to the science is going forward, the enabling technologies are going forward, and the missing component to get this thing across the finish line is more funding.
Yeah, there certainly is that interest. I mean, I've even had emails from the VC group I've done some stuff with.
Hmm.
But it seems to me, I mean, it's still, you're talking about all things nuclear, right? It's an incredible amount of capex required, and at this stage, an incredible amount, in terms of R&D.
Yeah.
It's a big bet, isn't it? I mean, it's a risky one.
I know it's huge, but if you win, you win the lottery, and you win a big Powerball when it happens. So I think it's that risk reward thing that goes into the technology. I think maybe another, after, talking to these investors and trying to raise, funds for a fusion company, it's a very interesting dynamic because, I mean, investors, they are going to think, strategically as they go into this. But in some cases, too, there's, not only are you thinking with your head, they're thinking with their heart, right? So there's another aspect of fusion that's really unique in how people look at this particular sector because of the transformative nature of this technology. So I don't know if that comes into play or not, but it's just a sense that I've had over the last few years that it's something that has always been pursued, and if I can be the one that gets this across the finish line, number one, that is a legacy that will last for eternity, but it will also is also going to make some people very, very wealthy.
Yeah. So let's end up there. So you're at the dinner party and someone says, "Well, it's always 10 years out." How convinced are you it's different this time? And can you give us some sense of who to watch and how to watch it, over these milestones over the next couple of years? And how have we really accelerated, turned the corner, and is this time different?
Yeah. So, I mean, first off, I definitely do think this time is different, and it's driven by, what we've kind of built up to at this point. It's the investment, it's the technology, and it's the science. And it's moving all of that on a scale that's relative, to where things were 50 years ago, 40 years ago, 30 years ago. So, and not to mention, things like AI and HPC coming into the play, what that can do to this sector, as we mentioned, to be able to actually, design and deliver a technology in silica as opposed to with concrete and rebar, that is huge, right? So those are advantages that the sector has. The sector itself, I think, is moving from kind of a scientifically challenged technology to an operationally and engineering challenged technology. So we've got to address things like materials. We mentioned in the beginning, when fusion occurs, it produces the 14.1 MeV neutron. There are no prototypical neutron sources today where we can expose materials to those energy levels of neutrons to understand the impacts on those materials. But we're having to design machines with that in context, right? So there's still a lot of work to do, I think, in technology development around materials, around lithium, which is going to be a key component in all of these, because lithium is used with almost all of these technologies when that high energy neutron comes out of the fusion reaction. As it interacts with lithium, it produces tritium. So you self-sustain your fuel supply with that being built into your fuel cycle. These companies also need to, further their plasma control systems. We need to develop the codes and standards. So, I mean, there are still challenges that have to be overcome, but I think as the funding level, continues to move forward, that's a piece of this. And the other big step, I think, just in the next 2 to 3 years, are some of these leading private companies who are actually building demonstration machines for proof of concept of their technology. And if any of these particular companies get this right and they do reach an energy gain, for example, I think Commonwealth Fusion Systems is shooting for a net energy gain of 10 to 12. So 10 to 12 times more energy out than you put in as a kind of first proof of concept. I think that component of any of these private companies is going to change the landscape once again. And the slope on that investment curve, will probably go close to vertical, right? So it's a big shift that affects the sector. And then underpinning that are countries like the United States and the United Kingdom who are moving forward with fusion regulations. There's a pathway. It's not going to be regulated like fission. It's, actually in the UK, they're not giving it to the nuclear regulator. They're giving it to their health and safety regulator. In the US, they'll regulate fusion like particle accelerators. Germany's picking up on this. Japan's picking up on this. So you're de-risking deployment through the development of these regulation components as well. And so as we do move forward, is an early 2030s timeframe possible for a prototypical power plant? The U.S. government is involved in this as well. They've got a cost share program right now with 8 different private fusion companies. Their goal is to have the leading companies in this particular mix deliver a preliminary design for a fusion power plant in 4 years. So a lot of movement on multiple fronts that really show it is very, very different today. The necessary components to take a technology to market are coming together, and it's just going to be the timing of how engineering challenges are met, regulatory functions come together, proof of concepts show delivery capabilities, power plant design coming together that take into consideration the necessary technology development to all come together on the time frame that's required for a particular company to actually say, here's my safety case, here's a license application to go build a new fusion power plant, work through that first of a kind regulatory exercise, and then put a shovel in the ground and see when we can turn one of these things on.
Fantastic. Well, Jay, I hope we can have you back in a couple of years and see where we are on this journey. I think I speak for all of us, perhaps those who, maybe in the fusion industry wouldn't agree, but it'll be, this sounds like something we all want to accelerate and will make a big difference. And hopefully you can keep us up to date as this story develops, and we'll make sure people can find you on LinkedIn and so forth if they want to further explore this. And I can imagine, as we've discussed offline, you've got a busy days ahead of you in terms of all the growing interest in the sector.
No, this has been a fantastic chat, and love to continue to talk further. It's an exciting space to be in, and appreciate the interest.
Thank you for listening. To find out more about HC Group, our global offices, and our expertise in search within the commodities sector, please visit www.hcgroup.global.